I'm Allison Williams, the project manager for Titus. Previously, we explained how a high-altitude balloon lifts and how they're used to collect data. We've also posted UAH's video of a high-altitude balloon launch. In this presentation, I'm going to explain the instrument used by UAH and then analyze the data that was collected. UAH's high-altitude balloon used StratoTrack APRS tracker. The instrument measures altitude, latitude, longitude, velocity, temperature, and pressure. The APRS sends the data packets in real time via amateur radio frequencies. The balloon was launched at UAH. It was supposed to travel to Cuba, but it landed off the coast of North Carolina. We graphed the altitude to see how the balloon would ascend. We thought it would reach its peak around noon. According to the data, the maximum altitude was actually reached around 4:40 p.m. We predicted that the higher the altitude, the lower the battery temperature would be. This was partly true. The temperature dropped as the altitude increased, but when it reached around 16,000 meters, the temperature began to increase. We predicted that the voltage would decrease as the battery temperature increased. However, the data shows that the voltage varied between around 1.2 volts to almost 1.6 volts. This is interesting because we wanted to see if the temperature would affect the battery while our CubeSat chief as it travels over the fires in California. We thought the temperature would be lower at night. The temperature did decrease during the night, but then the temperature decreased more from noon to about 1. Thank you for allowing me to share our project. Please follow Team Titus on Facebook, Twitter, Instagram, and YouTube, and our website.